Transmath 3, Unit 1, Lesson 7. Okay, so to start off, page 18 within your workbook, work through the skills maintenance, so pause the video and work through that. All right, now that you've worked through that, let's go through. We got 3/5 plus 2/9, and if you remember, in order to add fractions, we need to have a common denominator. So our denominators are 5 and 9. So finding that least common multiple, we got 5 and 9. Now, one way to find a common multiple is to multiply the two numbers, but that doesn't guarantee to be the least common multiple. So if I multiply those two, I know what 45 is. So let's just do our multiples up to 45 and see if there is one that is smaller than 45. So 5, 10, 15, 20, 25, 30, 35, 40, and 45. Then doing our 9s, count by 9s, 9, 18, 27, 36, 45. Okay, now in order to be a common multiple with 5, you need to have your ones place be a 5, and the first one that I see is that 45. Okay, so in order to do this, we need to find that equivalent fraction with a denominator of 45, and we got 3/5, and we want a denominator of 45. In order to do that, again, we got to multiply by 9. So we got 27 45ths, and for 2/9, we got to multiply by 5. So we got 10 45ths. So we got 27 45ths plus 10 45ths. Those are equivalent fractions. And when we add, again, add your numerators, the denominator stays the same. Now, that does not simplify, so that is our answer. So multiplying fractions, top times top, bottom times bottom. So we get 12 40ths. I see that both of those numbers are even, so I know for sure 2 goes into this. So let's go with that strategy. I know that it divides by 2. We get 6/20ths. Now, that doesn't mean that it is fully simplified. It is simplified compared to the original fraction, but it does simplify further. I notice again, they are both even numbers, so 2 goes into both. 3/10. Now that is the point where it is simplified. So if you notice that they're both even numbers, you can divide by 2, get it to a smaller or an equivalent fraction, but that doesn't guarantee that it will be, because the greatest common factor in this case is actually 4. Okay, so dividing both top and bottom by 4 for that 12 40ths gets you to the same exact point. Okay, again, multiplying 10 18ths. Again, I see that it is both even numbers in the numerator and denominator, so divide both top and bottom by 2, and we get 5/9, which is the simplified form. Okay, getting to division, again, keep, change, flip. So 5/7 times the reciprocal, 7/1, which is going to get us to 35/7. One thing I noticed that I know this is going to simplify, I noticed that 7 is in the denominator and in the numerator. Okay, so again, finding that smaller number of the two, 7, my factors of 7 are 1 and 7. And I know 7 goes into 35, so I'm going to divide both top and bottom by 7 to give me 5/1, which will be just 5. Okay, subtracting again, we need to have common denominators. So finding that least common multiple. Again, I know 12 is a for sure common multiple, but let's make sure. 3, 6, 9, 12, so I can stop once I hit 12. 4, 8, 12. From there, I notice 12 is the least common multiple. So 2/3, in order to get 2/3 to have a denominator of 12, I'm going to need to multiply both top and bottom by 4 to get 8/12. And then for 1/4, I want to get a denominator of 12 also. I'm going to multiply by 3 to get 3/12. So in this case, I'm really going to add 8/12 plus 3/12 to give me a total of 11/12. That does not simplify. Oh, sorry, we are doing subtraction. So subtracting that 3/12 to give me 5/12, and that does not simplify. Okay, again, division, keep, change, flip to get 4/3, and that one does not simplify as well. We could write that as a mixed number, as 1 and 1/3. We're not going to worry about that right now, though. Okay, so today we'll convert fractions to decimal numbers. Now, there are some common fractions that we would like you to just know the decimal to it. Okay, so like 1/4. 1/4, that is a very...
Lori Eddy to the main office, please. Lori Eddy to the main office.
Excuse that announcement. 1/4 is a common. Like, another way we say 1/4 is 1/4. Okay, how much is 1/4 worth? 1/4 is worth 25 cents. So 0.25 is the decimal number for 1/4. Now, if you think half, if you have half a dollar, you have 50 cents. Same idea. 0.5, I could write 0.5 as 0.50 if I really wanted to. Oh, where did we go here? Okay, so 1/2 is the same as 0.50, or 5/10 or 50 hundredths, if you want to think of it that way. Okay, or 3/4, 75 cents, so 0.75. Okay, another common fraction that we would like you to know is 1/3. 1/3 as a decimal number is 0.3 repeating. So if you remember 0.3 with a line over it, that is saying 0.3333, so on and so forth. It goes on forever. It never stops. Okay, so then 2/3, that's where you're going to get the 0.6 repeating, or 0.6666, and that goes on forever. Okay, 1/5. 1/5 is 0.2. 2/5, 0.4, or 4/10 is the proper way to say it. 3/5, 0.6. 4/5, 0.8. Okay, now, in order to really actually get these fractions, what you got to do is divide. We'll do that here in an example later on here, but let's convert the fractions to decimals and then solve the problem. So we need to convert those fractions to decimals and then add them from there. Okay, so again, 3/5. In order to figure that out, you do 3 divided by 5. That's all a fraction really is. Okay, now if you remember from our common ones, 3/5 is 0.6. Okay, going to that 4/10. 4/10 is going to be 0.4. 14/15, that's where this is the tricky one. Okay, 14 divided by 15. You know what, let's go ahead and let's do that one. 14 divided by 15. Okay, 15 does not go into 14. So what we need to do is you need to add a 0.0. We're not changing the value of it at all. We're just making it look different. Okay, so now I know 15 times 10 is 150. So 15 times 9 is going to be 135. And then from the next step, when we do our division, we subtract, we get 5, and we can keep adding zeros to the end of this until we find a pattern or it is done. Now, in our answer also, since we added a decimal, you need to have a decimal there. 15 goes into 50, 15, 30, 45. After that point, it does not go any further. So 0.93, multiply 3 times 15, get 45. And what you're going to notice, if we keep going with this, you're going to end up with the same thing. Okay, and that's going to repeat. Okay, so the part that is repeating is going to be the 3. So when we write this, it's 0.93 repeating. And if you notice, the line is only over the 3 because that is the part that is repeating. So now that we've converted all of our fractions to decimals, at this point, this is where we can add. Okay, I know 0.6 and 0.4 is 1. So then 1 plus 0.93 repeating, it's just going to be that 1.93 repeating. Okay, now if we did that as a fraction, our answer would be 58/30. Okay, so just given a fraction now, let's convert it into a decimal. Again, top divided by the bottom. So 8 divided by 3, or sorry, 3 divided by 8. Now, I know 8 doesn't go into 3, so that's again where we need to add that decimal and add a 0. And again, I can 3.00, I can write as many zeros as I want. Okay, because 3.0 is the same as 3. 3.00000 is the same as 3. We're not changing the value of that 3 at all. Okay, but now it goes into 3 0 times. I've hit that decimal, so I'm going to add the decimal. And then I'm going to look at 8 goes into 30 how many times? 8, 16, 24. So that goes in there 3 times. And we said it was 24. When we multiplied, subtracting, we get 6. And this is the point where we bring down that 0. Okay, and now we're looking at 8 goes into 60 how many times? Okay, so 8 goes in 60, 8, 16, 24, 32, 40, 48, 56. So 7 times. So and then we said 56, and we subtract, we're going to get 4. Okay, bringing down that 0, 8 goes into 40 5 times. And then in that case, we're going to get exact. And once we hit that 0 after that subtraction step, we know we are done. So 0.38 is equivalent to 0.375 or 375 thousandths is the proper way to say it. Okay, and the way we're going to say that, because the 3 is in the tenths place, the 7 is in that hundredths place, and the 5 is in the thousandths place. So the way we read this, you see that we start with the decimal there, 375, and it goes to the thousandths place. So that is why we say 375 thousandths. Okay, so we're going to use an area model to show that 3/4 and 75 hundredths is equivalent. Okay, we should know that 3/4 is 0.75. Cool. Sorry. Okay, so 3/4. Split up our square into 4 parts. Then we want 3 of those 4 parts. Now when we go to an area model for 0.75, since it is in the hundredths place, we got 100 boxes and we're going to fill out 75 of them. And when you do that, you notice they are equivalent. It's the same amount shaded within that area model. Okay, so work on your apply skills. Pause this video and work through that. So place an X on the number line in the appropriate location for each of the decimal numbers. 0.78, we're given the fractions, so I know that 3/4 is 0.75. So knowing these fractions again will help us. Okay? I know that this is 0.25, I know this is 0.5, I know this is 0.75. So 0.78 is going to have to be a little bit past that. So 0.78 will be found to the right side of that 0.75. Okay, and that's the explanation. I'm not going to write it out, but I know 0.78 will be just a little right of 0.75. So 1/4, 0.25, and I know 0.10 should be smaller than that. Now the thing here is I know that this is going to be a little bit closer to that 0. So halfway and just a little bit to the left. Okay, so knowing those fractions again as decimals is going to help big time when we're looking at decimal numbers on a number line. Okay, converting the fraction to a decimal number, 3/5, we should know that that is 0.6. Another easy one that I see is that 1/4. I know that's 0.25. Okay, going the other way, 0.3 repeating, I should know that that is 1/3. Okay, and then 0.75, I know that that is 3/4. Now, let's look at that 5/6 and converting that to a decimal. So again, top divided by the bottom. I know 6 doesn't go into 5. It goes in there 0 times. So 0, since I added a decimal, add that 0. 6 goes into 50 8 times. That goes to 48. And we subtract, we get 2. Okay, add another 0, bring it down. 6 goes into 20 3 times. 6, 12, 18. Subtract, and we get 2 again. And what you're going to notice is you're going to end up with that the whole time. So then 3 is the repeating part. So 0.83 repeating. Now, again, when we look at the point 10, we are at the 100th place. So our part is what we see, and the whole is the place value. So 10 over 100, which will reduce, since we can just take away those zeros, is 1/10. Okay, problem solving, drawing box and whisker plots. So we're going to be given a data set. And with that data set, we are given 3 things pretty easily. We can get our min, we can get our max. Okay, so the minimum, luckily it's in numerical order. This is our min, this is our max, and they have given us the median. And again, the median is just that middle number. Now, from there, what we're going to do is we're going to find the median between the green there. Okay, so we got 1, 2, 3, 4, 5, 6, 7 numbers. So that middle number, if you want to, one way to do it, boom, okay, mark one off top and bottom, and do it again, and then you're going to notice that Marcus ends up in the middle of that top group. Okay, so that's what we call our quartile. Okay, or you can say the median group for that. Okay, and that's where the box is going to come in. That's going to be the left side of your box. And then if we do the same thing with the second group, from Amber to Paige, so 1 on top and bottom until you find the middle, and Lamar. Okay, so that's called the quartile 3, or the median for your second group. Okay, so we had that minimum and maximum at 45 and 65, so you're going to draw that number line, 45 to 65, and label it as your min and max. Okay, then from there we found those upper median and lower median is how they're going to rephrase it as. I called them as quartile 1 and quartile 3. Okay, so that's your 53 and 62. That's where your box is. Okay, and then you're going to connect your box with your whiskers right here. And then you're going to mark inside the box. The median will always fall inside the box. You're going to mark your median. That is how you create a box and whisker plot. Okay, so that's all we're going to do for that. So our problem solving activity then, okay, we're just going to look at a box and whisker plot and pull data from it. Okay, so Isabel Martinez is the assistant principal at a middle school. She is looking over attendance data. She is particularly interested in one class where a number of students are absent on a regular basis. The table shows a list of data for the class and the number of days that students were absent for September, October, and November. Use this information in the box and whisker plot to answer the question. Okay, so is Micah absent a typical amount of time? Explain your thinking using the box and whisker plot. So let's go ahead, let's figure out where Micah is at. Micah is here. So Micah has missed 4 days in those 3 months. Now, when we look at that, is he gone a typical amount of time? Okay, that's where we're going to look into the box. Okay, the box is kind of where, you know, where everything is happening, where the average is happening. So Micah falls inside the box, and due to that, yes, he is gone a typical amount of time. And that's because he falls within the box. Because Micah is right here. So he's close to that average number of times gone for the class. Now, Carlos thinks he has a much better attendance rate than the rest of the students in his class. He has only been absent 2 times in the first 3 months. He tells his teacher this, but she says, no, you've missed about the same amount as everyone else. Explain why the teacher is right using the box and whisker plot. So since he was gone twice, okay, that puts Carlos right there, which again falls on the box. So really that's just a typical amount. So, you know, that's a typical amount of time to miss class. So he really is not missing less class than the average student in the class. Okay, so explain why the teacher is right. Carlos falls within the box. That is why the teacher is right in this case. And the teacher again said, no, he doesn't really miss less school than most. Now, what 3 students should the assistant principal bring into her office? Okay, this is where we got to look for those outliers. And when I look at the box and whisker plot, I'm looking at that big whisker to the right. That's telling me there's some people in that whisker that have missed a lot of school. So going to the data, okay, I see Carmen is missing 20 days. She's missing 22. Christina, 24. Okay, so compared to the rest of the class, you know, most of the classes miss between 2 to 5 days. Compared to that, those 3 students have missed a lot of days. So I'm going to say those 3 students. Carmen, Elena, and Christina. Okay. And the reasoning for this is they fall really far right on the box and whisker plot. If we mark those out, 20, 22, 24, they're really far right compared to the box. Okay, now I'm not going to write that, just know that they're really far right on the box and whisker plot, and that is why they should be called into the principal. All right, that is Unit 1, Lesson 7. Make sure you ask questions in class. Lesson 7 is your homework. Make sure to be working on that. Have a good day.